When you start Maple, you begin with a blank document. There are menus and toolbars at the top, as well as palettes on the side. You can start by typing in math into your Maple document and hitting return in order to see the result. You'll notice in this example that the result is returned on the next line. If you'd like to have the result returned on the same line, we can press Alt-Enter on our keyboard. Maple's context menus can be used to perform a wide variety of operations. For example, if we right-click on our output, we can integrate this with respect to X by using the right-click context menu. We can also generate plots using the right-click context menu by choosing Plots and 2D Plot. Math in a Maple document is live. This means you can go back and change your problem and have Maple update your worksheet for you. You can do so by changing a value in your input and then pressing the single exclamation point here in order to change the results. Similar to context menus, if you highlight an expression or a sub-expression, you can use the smart pop-ups in order to apply operations such as factoring, completing the square, or to generate 2D plots. Maple calculates exact answers. So if you enter in a fraction, your result will remain a fraction. Maple also calculates numeric approximations. So if we wanted to approximate this fraction here, we can right-click, choose Approximate to 5 decimal places. If your expression already has a decimal approximation, then the result returned to you will be in a decimal notation. You can also apply numeric formatting to your results by right-clicking and choosing the numeric formatting option, and then applying something like scientific formatting to our term. Maple's palettes feature over 1,000 different symbols that you can use to enter in expressions into your Maple worksheet. Here, for example, we can use the expression palette to quickly enter in an integral from 0 to 1 of x squared dx. There are many different palettes in Maple. For example, there's even a matrix palette that can be used to create matrices. Here, for example, we can create a 4x4 random matrix and insert that matrix into our Maple worksheet. We can also use the palettes to enter common symbols, such as pi, or we can use symbol completion in order to have an alternative to using the palettes. So say if we started typing in pi, we type this in just using our keys on our keyboard, so pi. If we hit escape, we can use symbol completion in order to complete this and make this show up as pi. Maple's interface is also case sensitive. You'll notice this in this example where x plus x is equal to 2x, but y plus y is equal to y plus y. Maple also understands implicit multiplication. So if I type in 3, then a space, then x, plus 5, then a space, then x, Maple will understand that what we mean here is that we want to multiply 3 by x. So we get the result 8x. This is an important distinction in Maple. So say for instance we enter in something like x space y, this is telling Maple that we want to multiply x and y together. Rather than if we enter in x, y with no space, this is just telling Maple that we want to have a variable named x, y. Maple also understands familiar mathematical notation. So say for example we enter in y and then type in two single quotes. These are treated as primes, so y plus y prime plus y is equal to 0. Maple understands this to be a differential equation. We can solve the differential equation using the right-click context menu and solving the dE for y of x. Maple uses label references. If we press Ctrl L on our keyboard, this will let us insert a value from a previous line. Here, if we go up to line 10 or equation label 10, we can type in 10 in order to retrieve the value x times y. Or if we wanted to multiply this by another term, we could just simply add in times x in order to get the result x squared y. In order to assign a value to a variable name, the colon equals operator is used. Say if we wanted to assign a value to the variable named xy, as we had before, we use xy colon equals 10. And then if we wanted to use this again later on, we could just type in the variable named xy and it'll contain the value 10. You can go over to the left side and you can open up the variables palette, and this will also show you any active variables that you have open during your Maple session. So in this case we can see that we have the variable xy and its value 10. In Maple, you can combine math and text in the same paragraph to help formulate mathematical sentences. So for example, if we enter in an integral, and we'll make this x cubed plus x squared plus 3, press the tab key to get to the x. If we hit Alt-Enter, we'll make this result be shown to us in line. Now we can go back to the beginning of the math. So put our cursor right in front of our math section and press F5 on our keyboard. You notice now that we've switched from math into text mode. I'll press F5 one more time so we see that change happening back and forth. And we can type in some text. So the integral. And we can now also go on, we can change this equal sign, as this equal sign is also text, to an is. So now we have a line with both text and math. Now, as we saw before, this is of course live math. So if we go back and change this, we can now press the single exclamation point in order to have our line of text and math be updated. Maple can produce 2D and 3D plots of equations and expressions, as well as animations. If we have an expression like sine squared of x, we can generate a 2D plot by right-clicking on our input, choosing plots, and then 2D plot. We can also modify our plot by right-clicking on the plot itself, right-clicking, and choosing to, say, change our line style. We can also export this plot directly from our context menu using the export options found near the bottom of the menu. We can generate 3D plots in a similar fashion. So say if we have an expression with two variables, x and y, we can right-click on this expression, choose plots, 3D plot with respect to x and y. By default, you can rotate the 3D plots, but you can also right-click and modify things like the color, lighting, and of course export from the bottom of the menu. Plots can easily be generated in Maple using the Plot Builder Assistant. If we right-click on an expression, we can go to Plots, then Plot Builder. And using the Plot Builder, we can choose the type of plot we want. So if we want to make a plot or an animation, as well if we want to change this to a contour plot or a 2D contour plot. We can also modify options by going into the Options dialog. This lets us do things like add a title, change the color scheme, and modify other properties of the plot. If we now click Plot, this will return the plot of this expression for us. The Plot Builder Assistant can also be used to generate animations. If we enter an expression with a parameter, in this case the parameter a, we can again use the Plot Builder, and in this case we'll change from plot to generating an animation. We'll change this to a 3D plot, and then we'll confirm that we are using the animation parameter a, as well as set the default values for a. If we press plot, this will return a plot to us, and now we can use the animation toolbar to play this back to see how this surface changes for different values of a. The Exploration Assistant allows you to instantly create interactive mini applications used to explore parameters of expressions. So again, if we have a command or an expression that we want to explore, In this case, we've got two parameters, A and B. We can right-click and choose Explore, and then use the Explore GUI in order to create our interface. By default, we'll use sliders. As you can see here, we can also change values for these, but in this case, we'll just leave everything the way it is. Let's choose to explore, and then what we have returned to us is a full interface. We can use these sliders to view how the surface changes for the values of A and B. Maple provides several tutors which are useful for teaching and exploring mathematical concepts in many different subject areas. You can find the tutors under the Tools menu, right here under Tutors, and then separated by various subject areas. For example, we can go into Calculus Single Variable and choose the Integration Methods tutor. With this tutor, we can enter in an expression, so in this case, sine of x squared, and then we can proceed to apply rules in order to step through the integration. Another source of interactive content in Maple is a collection of math apps. If you go to Tools, Math Apps, this will open up the Math Apps Guide. Here you can browse through the several hundred math apps which are available in Maple. And to give you an idea of what math apps look like, we can go to the Calculus section and open up the Solids of Revolution math app. So this is a math app in Maple. You can see here we have a main section which explains the concept, and then below there are several interactive components in Maple that we can interact with. As you can see here, we can draw a line, and on the right side of your screen you'll notice as the line is being rotated around an axis. There are many different math applications in Maple in various subjects. While many operations in Maple can be done through the use of context menus and other interactive tools, Maple also has a rich programming language. If we enter in a new variable, call this m, and we'll make this a matrix, and we'll fill this up with 1, 2, 3, and 5. This will be the matrix we'll work with. We can then use commands from various packages on this variable. You'll find that many commands in Maple are grouped together in packages. Now normally you can start with the long name of the command, something like linear algebra, and then we'll use the determinant. And you'll see that when I'm typing, I actually have a little pop-up here that I can use command completion by hitting the tab key, and then have Maple fill in the rest of my command name for me. But we can use the long name of our Maple command directly to our Maple variable. So in this case, we type in linear algebra determinant of m. Now this is, of course, in contrast to just using determinant of m, which will just return back the same results to us, because there is no top-level command inside of Maple called determinant. So determinant in this case is a command which is featured in the linear algebra package. Now if we load the linear algebra package, we can use the with command to load the linear algebra package. Then when we go back here and use determinant, it will work because the linear algebra package has been loaded, and that means any commands in the linear algebra package have been made top level. If you go to Tools, you can see a list of a lot of the commonly used packages under the Load Packages menu. And for a full list of packages available in Maple, you can click on List All Packages. For more content on learning Maple, you can go to the Maple Help System and view topics under the Getting Started table of contents group. For example, we can ask and answer questions such as how do I enter a complex number, or how do I enter a matrix, how do I plot a function. In addition, we can step through tutorials on things like talking to Maple, on plotting, on working with data structures and data manipulation. This is all available within the Maple Help system.